Hi everyone, so in this video I just wanted to clarify some topics about function notation. So function notation is something that we use once we've determined that a relation is a function. So suppose that you have the equation y equals 2x plus 1 and you've determined that it's a function. Well, instead of writing y, you can actually write f of x. So f of x is this f with an x in parentheses. This does not mean f times x. Okay, I know we're used to seeing the parentheses and thinking it means multiply, but that's not what it means. This means f of x, and that's how it's read. So this means that y is the output, f is the name of the function. So f is the most commonly used letter because we're talking about functions, but you can actually name your function anything you want. You can call this q of x. You can call it p of x. You can pick any uppercase or lowercase letter that you like when you're naming your function. The x is in parentheses because x is the input value. So what we can do is instead of writing y equals 3x plus 1, we can write f of x equals 3x plus 1. Notice that this f of x has just replaced y. So instead of writing y equals 2x minus 7, we can write f of x equals 2x minus 7. So we can also use function notation where we're trying to find specific values. So instead of saying evaluate y equals 3x plus 1 when x equals 2, we can say given f of x equals 3x plus 1, evaluate f of 2. So instead of saying evaluate y equals 2x plus 7 when x equals negative 1, we can say given f of x equals 2x plus 7, evaluate f of negative 1. So let's just talk about what this means. So remember, if you're given f of negative 3, okay, f is telling you the name of the function, and then negative 3 is telling you the input value. So this is saying evaluate the function at a specific input value. So in this case, x equals negative 3. Remember, the value of the function will be y since y equals f of x. So how do we evaluate this with a graph? So it says find f of 5. So f of 5 is another way of saying what does y equal when x equals 5. So I'm going to go to my graph and find x equals 5, which is right here. At that place, I have the coordinates 5, negative 3. Okay, so I have x and y. So that means that y equals negative 3 when x equals 5. So f of 5 equals negative 3. What about f of 0? So this is saying what does y equal when x equals 0? So I'm going to go to my graph once again and find x equals 0, where I have the point 0, negative 4. So 0 is x, negative 4 is y. So that means that y equals negative 4 when x equals 0. So f of 0 equals negative 4. So what if we're evaluating from a table? So we want to find f of 2. So f of 2 is saying what does y equal when x equals 2? I go to 2 in my table and notice that it has the y value 7. So y equals 7 when x equals 2. f of 2 equals 7. Now it wants me to find f of 3. So I'm going to go to my table, find 3. When x equals 3, y equals negative 4. Okay, so y equals, when x equals 3, is negative 4. So f of 3 equals negative 4. So when we're evaluating from an equation, this says evaluate f of x equals 4x minus 2 for x equals 0, 1, and 2. So we have this equation, f of x equals 4x minus 2. To find the value at 0, we're going to evaluate f of 0. That means we go to our original equation. Wherever we see an x, we're going to plug in 0 instead. So that gives me 4 times 0 minus 2. Now we just need to simplify this. So 4 times 0 is going to be 0. Then I have minus 2. 0 minus 2 will be negative 2. What if I'm trying to find 1? Once again, I'm going to go to my equation and plug in a 1 everywhere I see an x. So 4 times 1 is 4, and then we have minus 2. 4 minus 2 is 2, so f of 1 equals 2. What about 2? So we plug in 2 for x, so we get 4 times 2 minus 2. 4 times 2 is 8, so we have 8 minus 2, and then f of 2 equals 6.